Hello, guys. Welcome to Yebo Physics on a Thursday afternoon. My name is Arnold, and I am going to be with you this afternoon. If you are on Teams, you're welcome. If you're on YouTube, you're welcome as well. Please feel free to interact with us via the chat box. If you're on Teams, also feel free to unmute your mic and interact with us as well. It'll be good to have an interaction with you guys this afternoon whilst we're solving physics problems together. So please, if you're on Teams, just to confirm if you can hear us from the studio. If you're on YouTube, please do confirm that you can also hear us. All right, you can just type in the chat box just to confirm before we begin our problem solving session this afternoon. To have an interaction with you guys. So what do we intend to cover today? We intend to look at vectors. We are going to be taking it up from question 11 for those doing PHYV 101. We're going to be solving problems from tutorial 1, and we're going to be taking it up from question 11 to 15. So the previous questions have been solved in the previous tutorial. Yesterday there was a session which was recorded for you, and on Tuesday there was another session again which was recorded for you. So in case you may have missed any of those sessions and there are questions that you really want to go through, please do look for those recordings on YouTube. You should find them there. So we are going to be solving questions from TAT 1 on PHYV 101, that is from question 11 to 15. Then for FVV 101, we're going to be looking at questions on section 5.3 to section 5.7. So we're going to select questions that we're going to solve there. So in case you have your question or any question that you think you need further assistance on the sections that I've highlighted, please do indicate so that you can get the help that you need. So we should be getting started. Should be getting started now. I can see I have got company on YouTube. That is good. Feel free to type your questions or contributions in the chat box, okay, at any given time, and feel free to stop me at any time in the event that you have a question or you have a contribution that you wish to make. All right, so let's get started. So we said we're going to be starting with question 11. I hope you can clearly see the questions on the screen there. Question 11. Right, that's our question 11. So first and foremost, we're given an instruction on our question 11 there, which reads, on occasion, the notation A bar can be given in that form where A bar is A cos theta in the I direction plus A sin theta in the J direction. So in the event that we are given in that notation, we now know what to do. All right, so let's get started. So there we are. So the question reads, if vector A is given by that and vector B is given by that, what is the magnitude of vector C? And vector C is 2A bar minus B bar, or 2 times vector A and minus vector B. So we are going to write down the data that were given for question 11. And vector A is equals to 12i minus 16j, and vector B is equal to negative 24i plus 10j. And our question is looking for the magnitude of vector C, which is equals to that minus B. So to do that, what we need is to multiply vector A by 2. So that's going to be 12i minus 16 in the j minus vector B, which is going to be 24 in the I plus 10 in the j. So that's negative, right? That is negative. So our vector C becomes 24 in the I minus 32 in the j. That becomes minus vector B, where we have got 24 in the I plus 10 in the j direction. Okay. So what then do we need to do? So we add, or we have to subtract the components in the I direction alone first. So that is going to be 24 minus 24, all this in the I direction. Okay, then it will be negative 32 in the j minus -10 in the j, or let's maintain the same notation, minus 10 in the j, like that. All right, so that will give us 48 in the I. 32 minus 10, what will that give us? Negative 32 minus that, it will give, okay, so we can just say that's negative 32 minus 10 will give us 22, right? 22 in the j. So that becomes our vector C. So we have established our vector C, but that is not what we are entirely looking for. The question says we need the magnitude of this vector. So if you are following, and you should be able to suggest how we can find the magnitude. You can type in your comment. How can we then find the magnitude of this vector now that we have expressed our vector in the I and the J direction? How then can we find the magnitude of this vector? So if you're on Teams, you can unmute and share with us your comment, or you can simply type it. If you're on YouTube, you can also simply type in your comment. How do we find the magnitude of vector C? All right, waiting for responses. So if you have been following in your lectures, to find the magnitude of vector C, we would then square root of 48 squared, right, plus 22 whole squared, or negative 22 squared, to get the magnitude of vector C. And now we have to punch that to get our numerical value.
I'm back.
Hello. Hello. I see some company there on Teams. So we can punch that now. So we need the square root of 48 squared plus 22 squared. We'll get 52.3. So the magnitude of our vector there is 52.3 degrees. So let's see how we are supposed to represent our answer. All right, so is this the... All right, so something is amiss there. We can just see what do we get, or what are we supposed to get. What are we supposed to get? What are we supposed to get? Right, I'll just scroll up to just begin a new preview of the questions. All right, let's comment. Are you getting the answer that I'm getting as well there on that part of the question? Or we are getting different answers? I am getting 52.8. Is that what you are getting as well? So I just want to begin on a new preview. Right, so seems like I am not able to do that. Let me see if I can. Right, I got that. Seems like I got that now. So let's go back to our question and see if we have an option for the answer that we are getting there. So for our question, we are getting 52.3. We're getting 52.3 instead. Let's see, we don't have any answer that has got 53 there. Is it possible that we may have made a mistake somewhere? Let's check again. Let's check again. Let's check again. Just to see if I punched that correctly. 48 squared plus 22. So we can try and go back again just to be sure one last more time. So we had question 11, and our vector A is 12i minus 16, 12i minus 16, and vector B is negative 24 plus 10, negative 24 plus 10. Then we're looking for 2a minus b, 2a minus b. All right, so this is our 2a minus b. This is our 2a minus b. So it's going to be 2 times that. We'll get 24, and 2 times that we'll get negative 32. So this is our vector 2a. 2 times 12, that's 24. 16 times 2, that's 32. Then it becomes minus vector b. Vector b, we have negative 24i plus 10j. So our vector b is okay. Vector b is quite okay. Then what else do we need to check? Now we are now adding components in the I direction. So we are adding this 24, combining the I terms, so that becomes 24 minus 24. We'll get a 48. We'll get a 48 there. Then we have the j component. The j component, we have negative 32. Negative 32. So there is our negative 32. Minus 10. So it's going to be negative 32 minus 10. So minus 32 minus 10 is going to be minus 42. So I see where the error was. So I didn't do the maths correctly there. So I left out the negative 32. The negative 32. Let's just make it clear here. I left out the negative 32 because our j component on our on vector 2a is negative 32 minus 10. So this becomes 48 in the I minus 32 minus 10. It'll give us negative 42. So that would be negative 42 in the j. So that becomes magnitude becomes 48 in the I plus 42 in the j. Okay. Right. Then to find our magnitude, that becomes the square root of 48 squared plus 42 all squared. So let's correct that. Becomes 42, and we get now 63.78. And looking at our answer, we have got to round it up. That will be 64. And it's not even an angle, it's just the magnitude, not the direction like what I'd done in the last. So it's just the magnitude of the vector. All right, so that was the mistake that I'd done there. So I hope you guys will notice that we need to be careful when it comes to our addition and subtraction. All right, I missed that one. So it's very possible to mix up the signs there, so you guys should stay alert. So let's just check our answer. So indeed it's 64, which is what we are expected to get. So let's move on to question 12. Question 12. Right, so in this case now we are given vector A being equal to 1580 degrees, and vector B is 12 in the I minus 16 in the j. So what are we asked to find? Well, we have to find the magnitude of vector A minus vector B. So what do we have to do? We first have to express these vectors in the same notation, right? In the same notation. So we're going to express vector A in the notation given there. So we are told that A is same as A cos theta in the I plus A sine theta in the j. So which means our vector A is going to be equals to, if you look at the notation, it's going to be 15 cos 80 in the I direction plus 15 sine 80 in the j direction. That becomes our vector A. All right, so we've expressed this in the same notation so that we can add or subtract the two vectors in a similar way, right? So now let's look for vector A minus vector B. Vector A minus vector B is going to be equal to So we're going to add what is in the j and what is in the I, all right? So in this case, we are actually subtracting, so it's going to be a minus b, so the component of a in the I minus the component of b in the I as well. Then we say the component of a in the I in the j minus the component of b in the j. So we're going to show this. So we start with the j with the I direction. So we can start with the I. So it becomes 15 cos 80 minus 12. So that becomes 15 cos 80 minus, let me just bring this here. A, it's 15 cos 80 minus 12. All this is in the I, right? Then minus in the j direction, what we have, it's going to be 15 sine 80 minus, it becomes minus what? There we said minus 12, so it's going to be negative 16 in the j. All right. So we are adding that now. So what do we get? So in the I, it's going to be 15 cos that. We now need our calculator. Cos 80 put a bracket there. 15 cos 80 that's minus 12, right? We get 9.395. Then we're going to have our 15 sine 80 plus 16. So we'll get 30.77. Okay. Now, since we want the magnitude, magnitude for A bar minus B bar, it's now going to be the square root of that 9.395 all squared plus 30.772 all squared. Let's put that together. plus 30.77 all squared, we get a magnitude of 32.17. If you look at our answers, they are just given to two significant figures, so I think it's fine that we give that just that. That becomes our magnitude. Right, we might as well check if this is the correct answer which we are getting. So indeed it is the correct answer. 32. So the magnitude is indeed 32. So basically what we did there was to first express these two vectors in the same notation. After I've done that, we then deal with the components in the I for vector A and vector B. Then we deal with the J direction alone for vector A and vector B. Then we get our magnitude by making the square root and the square in the I plus the square in the J direction. So that is what we have done for that second part of the question. Right, so moving on, I think we can move on to the next question if there are no questions. Question 32. So we are given, no, it's question 32, question 13. Question 13. So what are we given? Vector C is given as 10 meters in the direction 30 degrees, and vector D, it's 25 meters in a direction of 130 degrees. What is the magnitude of the sum of these two vectors? So what the question is looking for is the, sorry, I'm now used to vector A. This time we have vector C. So this is what the question is asking, okay? So we are going to change the notation that we have so that vector C becomes, vector C will now become A, what's happening, 10 cos 30 in the I plus 10 sine 30 in the J direction. Do the same for vector D. It will be 25 cos 130 in the I direction plus 25 sine 130 in the J direction. Okay. So that is what we are given there. Now we can simply add, the I components together and the J components together to get the sum of the two vectors. So to get the sum of the two vectors, we will now have vector C plus vector D. is now going to be equals to, we deal with the I direction first. It's going to be 10 cos 30 plus 25 cos 130, right? And we're summing these two vectors. Now we deal with the j vector, which is going to be 10 sine of 30 plus 25 sine 130. And we notice all this is in the, this is the j direction, and this is the I direction. Now when we've done this step, we can now sum from our calculator the I component of vector C plus vector D. We can sum that now. We can sum that now from our calculator. Clear everything. So we have 10 cos 30 plus 25 cos 130 what do we get? We get negative 7.4. That's what I'm getting. It's negative 7.409. Okay, plus the component in the j. Let's add the j. Make this j clear. Clear that. It's going to be 10 sine 30 plus 25 sine 130. We get a 24. If you punch that, you'll get a 24. I hope you are also punching in to confirm if we are getting similar answers. So I'll give it as 24.151. So this is the sum of vector C and vector D. So what we have to do is now to find the magnitude. C plus D equals to the square root of negative 7.409 squared plus the square of 24.151 all squared. We punch this again. We punch this to our square root, and we have our negative 7.409 squared. What happened? Okay, plus no. What have I done? I've moved out of my plus 24.151 squared. We can remove this. So we get 25.26. Please confirm if we are getting the same answers there. So let's just confirm if our answer is correct. So our answers have been given in that form. So this is 25 meters. That's our magnitude of C plus D. Is that okay? All right, so moving on. Let's look at question 14. So whatever question 14 says, the diagram below shows the path taken by a sailboat taking sideways because it cannot sail directly into the wind. All right, so that's question 14. And so this is what we have, and this is north, and this is east. And at that point, we have got 1,000 meters, and this is our origin. We move from the origin to B, from B we move to C, and this is around 1732 meters, and from C we move to D, and from D we move to E. Okay, so what does the question say? Use this exhibit to answer the following questions. The total displacement of the sailboat. Okay. The vector sum of its displacements OB, BC, CD, and DE is. So we want the vector sum, or the total displacement. The total displacement. Okay. So we're moving from OB to BC. From BC we go to CD, and from CD we go to DE. Right, so we want the resultant. So you then look at what was our starting point. Our starting point was at O. And where are we? We are now at E, which is the finishing point. So this is our reference starting point, and this is our finishing point. Okay. So what do we do now? So which means our displacement is going to be from this point to this point. So that is our OE. That would be our vector OE from that point origin to E. Okay, and our displacement is started at 0 there, and at E it's 6298, and this is our north and this is our east, so this is due east. So our total displacement is 6298 due east. And we have that option there. We have that option there. Right, so that is how we're supposed to analyze that question. 6,298 meters due east. Right, then the next question, question 15, which is the last question on the questions from the PHYV 101. So it's question 15. What does it say? Question 15. So we're given vector C equals to 10 meters, 30 degrees, and vector D is equals to 25 meters in a direction of 130. What is the direction of the sum of these two vectors? Okay. So this information that we're given here is similar to the information that we are given in question 13. Do you realize that? Okay. Because to find the direction, we should first find the magnitude of the sum. Okay. And we had already worked this out, the magnitude of vector C and D. Actually, we don't need the magnitude, we need the sum, just the sum. Just the sum, so that we can find the direction, and we have it here. We have it here. Okay. So it's negative 7.409. Negative 7.409. Negative 7.409. So just going to write it down, negative 7.409 in the I plus the J component, which is 24.151. 24.151. 24.151. That is in the J. Okay. So moving on, what do we have next? To sketch and see in which axis we are in. Or which quadrant rather. So the x is negative, so we should be there, and our y is positive, so we should be there. So that becomes which gives us to be in this direction. Right, so we can choose to close there and form our right angle triangle. And we make our angle theta there. And our y-axis is 24.151 meters. And here we've got negative 7.409. So we now use our trig ratios to find the angle theta there. Theta, okay, let's say tan theta, since we have the opposite and the adjacent. Tan theta is y over x. Right. So our theta is going to be arctan. Our y is 24.151 over 7.409. That's our angle theta there. Now we have to punch. And clear that. Arctan. Need a fraction. That's 24.141 all over 7.409. So we get an angle, this angle, theta, to be 72.9. All right, but is this our answer? Is this our final answer? That's what we should ask ourselves. Certainly it's not. We always move from the x-axis in an anti-clockwise direction to get the direction of the vector. Okay, so our alpha, which is what we're looking for, is going to be equals to, since this is a straight line, it will be 180 degrees minus 72.9 degrees. So minus, okay, let's just say we get 107 degrees, and that is what we get. That is what we get for our answer. We have to check if we have any of those options. Question 15. We have that option there. You can check. So indeed, our correct answer will be that. So if we were to express our vector c plus d with its direction, this will be its direction, and the magnitude, we did find the magnitude as 25. So which means c plus d can also be represented like this, 25 meters with an angle of 107 degrees. So you can express your answer like that if the question asked for both the magnitude and the direction. That is how you would express your answer. So this is it, guys, for the questions on PHYV 101. So these are the questions on, these were the questions on your tutorial. So we did answer questions from questions 11 to to 15. All right. Like I mentioned, the previous questions have been answered, and the recording is available on YouTube in case you missed the live sessions. Okay, so now what we want to do, we want to solve questions, select questions that we are going to work out together from PHYV 101 workbook. All right. FVV 101 workbook. So for those that are doing FVV, so I'm just going to close this window. All right, so let's select the FVV 101 workbook. This is the FVV 101 workbook. So we are going to be interested in looking at a few questions from here. So let me know if you've got any questions. Let me know if you've got any questions. So we're going to start with the question that we have here, which is similar to some of the questions that you may have come across. So it's quite similar to some of the questions that you may have come across even when we're looking at the PHYV 101 questions. You'll realize that the questions are quite similar. All right. So we can start with this question 2. So let's read through the question. It says we've got vector A and we've got vector B in the I and J direction. What are we being asked to find? What are we being asked to find? We're being asked to find the magnitude. First, what are the magnitudes? Oh, first the sum. We're first supposed to find the sum, then the magnitude, then the direction. So we're going to rewrite our vector A is equals to 4.0 meters in the I plus 3.0 meters in the J, and our vector B is equals to negative 13.0 meters in the I plus 7.0 meters in the J. And what are we being asked to find? What are we being asked to find? What are we being asked to find in that case? the sum, right? So it's going to be vector A plus vector B equals to, sum up the I components. So it's going to be 4.0 meters plus negative 13.0 meters in the I direction. Okay. Then we move on to the J components. It's going to be 7.0 meters plus 3.0 meters in the J. And what do we get? That becomes 4 minus 13. That becomes a negative 9.0 meters in the I plus 10.0 meters in the J. So that is our sum. Okay. Then the question says find the magnitude as well. So we need to find the magnitude as well. So the magnitude of A plus B will now be equal to that is our magnitude. So we have to clear that first, then put our square root. Square that plus 10 squared. We'll get 13.45, right? We'll get 13.45. That is what we get. I hope you are following. I hope you are following. I hope you are following. In case you're not, please let me know. I'm just going to pause for a while. So that becomes 18.45. That is in meters, right? And the next thing that we do is to find the direction. So to get the direction, we first have to sketch. So if we were to sketch to see in which quadrant are we going to be, so we now have to check our x or our I component is negative, so we should be somewhere here, but our y is positive, so we should be in the second quadrant. So if we were to sketch, should have something like that. Then we can make our right angle triangle there, and we can make this angle theta, and on our x-axis we've got -9, and here we've got 10, right? And to get this angle, we have got the adjacent and the opposite, so we have to use tan theta. So tan theta is equals to the y over the x. So theta will be arctan y, which is 10 over 9. And we have to punch that. Arctan so we get 48 degrees. But is this our answer that we need? So the question says we need the direction of a plus b relative to the I direction, relative to the I direction. So we then have to move from the I direction, which is the x-axis, going to where our vector is, counterclockwise. So to get our angle alpha there, alpha will now be equals to 180 degrees minus 48 degrees. If you compute that well, you should get I wanted to guess, but let me not guess. 180 minus 48. 180 minus 48 equals to 132, right? Equals to 132. So this becomes our angle. That becomes our angle in question, right? Right. So, like I said, it's the questions are quite similar to the questions that we've been looking at on the model questions. So the concepts are quite similar. So there's really some similarities in what you are doing. Then question 3 is asking for us to find the magnitude and direction of the resultant force that originate due to the forces in the following figures. All right, so which means we need the resultant in the x. So we've got 1, 2, 3 forces. Okay, so to sum forces, we should sum them. We can only sum forces that are in the same direction. Okay, we can only sum forces that are in the same direction. That's where the concept of resolving comes into play. All right, so we'll look at forces in the x direction first. So we'll find the resultant in the x. So our vector number 1 there, it has no component in the x direction. It's entirely in the y, so it's going to be 0 there. And vector 2 has got positive 5 newtons. So that's 5 there. Okay. Then vector 3, we realize that vector 3 has got a component in the y. It also has a component in the x. Okay, so what can we do? We can choose to, we can have a right angle triangle there, right? We can have our right angle triangle whereby we can actually close there, all right, such that our triangle becomes like this, like that. No, not like this, not like that, definitely. It should be like that, like that, right. We have our right angle there, we have our angle of 70 there, we have a magnitude of 6 Newton there, and this is our x and this is our y. And look, we are looking for x, which is our adjacent, and we've got our opposite, so that becomes a cos, right? Cos sine theta is equals to adjacent over the hypotenuse. So that would be cos theta equals to our adjacent 70 over the hypotenuse, which is 6. No, what have I done? What have I done? Cos 70 is equals to our adjacent, which is x, over the hypotenuse, which is 6 newtons. So our x is 6 cos 70. So the component of 6 newtons in the x direction is going to be negative, because we are on the negative x-axis. So this becomes minus 6 cos 70, right? You might as well sum that. That becomes 5 minus 6 cos 7. We'll get 2.95. 2.9. Okay, we can just say 2.9 newtons in the x, then our resultant in the y. The first vector is already in the entirely in the y, so it's 4 plus 0, because vector 2 does not contribute. The 5 newton doesn't contribute in the y-axis. Then we come back again to our triangle. Now we're looking for y, so it's going to be sine 70 equals to the opposite, which is our y, the one that we're looking for, over the hypotenuse 6. So our y is going to be equals to 6 sine 70, and this is in the negative direction, so it's going to be negative. So it will be negative 6 sine 70. And now we have to punch that. That becomes a 4 plus 4 minus 6 sine 70. We get 1.6. So 1.6 newtons. Okay, and the question says we should find the direction. So meaning to say we should now sketch so, oh, that's negative, so this should be negative. 2.9 was positive, so our y is negative, so meaning that we should be in this direction, and our x is positive, so we should be in this quadrant. Okay, and we can choose to close our triangle there. and we have our angle that. We now know that our y is negative 1.6 and our x is 2.9. And we now know that tan theta is equals to opposite over adjacent, which is equals to 1.6 over 2.9. So theta is equals to tan 1.6 over 2.9. And punch that. We get 28.9. But again, this is not our answer. We should move from here up to there. So we'll call our angle alpha. So our angle alpha will then be equals to 360 degrees minus 28.9. Okay, 331.1 degrees. So that is what you're supposed to get. Alright, that becomes your angle for that part of the question. Let's see if there are any questions. I don't see any questions. Please do remember to feel free to stop me at any point in case you have a question or in case you want us to interact, which is what we are looking forward to. So feel free to stop me at any time if you've got any contributions. If you're on Teams, feel free to unmute your mic and share with us. Right, if there are no questions, if there are no comments, let's move on to the next question. So you realize that we have a question that is almost similar to what we have there. So we're going to do this one a bit quicker than we did the first one because you are already getting familiar with how we should be solving these problems, right? So let's get our r in the x. So we'll call this our vector 1, this will be vector 2, and this will be vector 3. So this is going to be like that. This will contribute, right? So to get this x, we have our hypotenuse, which is 10 newtons. So we're going to use adjacent and hypotenuse. It's going to be cos. So it will be cos 60 equals to adjacent over hypotenuse over 10. So which means our x is going to be equals to 10 cos 60. So that becomes 10 cos 60. We come to the second vector. This one does not contribute, right? Then does not contribute in the x. Then if we close there, here we've got our x, and there we've got our hypotenuse, which is 6 newtons. So we've got adjacent and the hypotenuse. So again, it's going to be cos 40. Our adjacent is x over the hypotenuse, which is 6. So x is going to be equals to 6 cos 40. X is equals to 6 cos 40. And this is negative because we're on the negative side of the x-axis. Alright. So we said vector number 2 does not contribute, plus a negative 6 cos 40. Okay, so we can add that. That is 10 cos 60, 10 cos 60 minus 6 cos 40. Right, what do we get? I'm getting 0.40, so 0.4 newtons. I work out for r in the x or in the y now. Our vector 1, does it contribute? Yes, we've already formed our triangle. Now we're looking for the y. It's going to be sine 60, which is opposite, is the y, over the hypotenuse 10. So y is going to be 10 sine 60, and this is positive. 10 sine 60 plus 7 newtons in the negative direction, so minus 7 plus, now we have to find y there again, so that will be sine, this time around, sine 40 equals to the opposite, which is the y, this time over the hypotenuse, which is 6, so our y becomes 6 sine 40, 6 sine 40. That's what you should be having. Now we have to punch that. We have to punch and see what we get. 10 sine 60, 10 minus 7 plus 6 sine 40, I get 5.5. If you are punching along with me, that is what you should get as well, 5.5 newtons. Now what we do, we then put up a sketch to find our direction, and both of these are positive, so that becomes so x is positive, y is positive. We should be somewhere. We should be in this quadrant actually. So we can put that and close there, find the right angle. X, we got 0.4, y, we got 5.5. And remember, to find the angle, theta is equals to arctan, the opposite over adjacent, 5.5 over 0.4. Right, so our theta, we get 85. .8 degrees, and here we are already moving from our x-axis up to where our vector is, so this becomes our answer for that direction. Okay, That is for B. In case you have got any questions, please do let me know. In the event that there are no questions, let's move on to the next question, question C. Right, so we are still doing the same thing. We are going to find the resultant in the X. And both of these should be resolved, right? Okay, if I close there, it depends on which side I'm going to close, doesn't matter. So I can choose to close there. I have my right angle there, right? And I'm looking for this X, okay? And I have my hypotenuse, which is 5. So meaning that to get the X component is going to be cos 30 equals to the adjacent, which is X over the hypotenuse, which is 50. So X is equals to 50 cos 30, right? And if I have to do for this one as well, close there. Oh, now I have to close the other side. If we close there, right? Our angle is 60, so cos 60 is equals to our adjacent, which is X, what we're looking for, 28.9. So our X is equals to 28.9 cos 60, right? That is for this X. So now to find our, so this is negative because we're on the negative side. So if we are to start with this one and this one secondly, it's going to be 50 cos 30 plus negative 28.9 cos 60. You can punch that in our calculator. 50 cos 30, 50 cos 30 minus 28.9 cos 60. We get 28.85. That is what we're getting. Not sure if that is correct. Not sure if I did that correctly. Cos 60. That's around the X. Oh, right. We have a mistake that we've done there, guys. Yeah. So this time it wasn't adjacent. It wasn't adjacent. It was meant to be sine. Ooh. So we really need to be careful. I had a big mistake. Right, so looking at the orientation of my triangle there, this is where my adjacent is. And our X in this case is the opposite. And our X there is the opposite again. Which means that to find X, we should use sine ratio. Sine ratio. So sine 50 equals to X, which is opposite, over the hypotenuse, which is 50. So our X becomes 50 sine 30. Our angle is 30, right? Okay, I'm seeing a comment from Bridget. So you don't resolve the angle when finding components. We are actually resolving the vector. If you are following Lindobuhle, we are resolving the vector, but to resolve the vector, we actually need the angle, which is between the vector and either our y-axis and the x-axis. So we need the angle to resolve. We definitely need the angle, just like we are doing. So the angle is the one that is going to help us to resolve the vector in the x and in the y. So the angle is always there when we're resolving. So basically you are forming your right angle triangle, then you look for the missing side that you want. So if you have your right angle triangle, which is this one, for example, 1, the missing side there, which we're looking for in the x direction, is this x. And in this triangle, it's the opposite to this angle. So this x is on the opposite. So which means the trig ratio that you can use, considering that we have the hypotenuse, which is 50, it becomes sine. Because sine is opposite over the hypotenuse. Okay, which is what we've done there. Then we do the same for this side. Still, this is our angle, so this is our opposite, so it becomes sine 60, and our opposite is x over 28.9. So our x becomes negative 28.9 sine 60. Why negative? Because it's on the negative side of the x-axis. Alright, I see you have a follow-up question there. You are saying the angle in the second quadrant, is it not supposed to be 180 minus 60? So we are already given the angle in the second quadrant. Unless you wanted to resolve it in another direction, we will still get the same answer, but it will no longer be 180, it will be, I think you wanted to say 90, right? Are you referring to this angle K that I've just put there? Is that the angle that you're referring to? You can type your comment. Would have been good if you were on Teams, so that you were going to unmute and we could actually verbally communicate. So the angle in the second quadrant that you are referring to, is it the angle K that I've highlighted there? Is it the angle that you're talking about? Then we take it up from there. Is it the angle K that you're talking about, Lindobuhle? Good. So you're saying, yeah, so, all right. So to get that angle K, will it be 180 minus 60, or it will be 90 minus 60, this angle? That's a right angle, right? So will it be 180 minus 60, or it will be 90 minus 60? You can give your response there, so that I can assist you from there. Waiting for your feedback. Lindokuhle. To get angle K there, we have a right angle triangle. And part of it is 60. Lindokuhle, we are waiting for your response. I see Prince has got another question there. He's saying, is the hypotenuse is 28.9? Yeah, in terms of I hat, it's going to be 90. It's going to be 90 minus 60, which is going to be 30, right? So do we agree that the angle K there is 30 degrees? The angle K there, do we agree that is 30 degrees? Let's first address the question that Lindokuhle has. If we agree on that, then we move to the query that Prince, the question that Prince is giving, is highlighting. So Lindokuhle, if we say 90 minus 60, angle K will be equals to 30 degrees. Do you agree to that? Okay, great. You do agree. Okay, so I want to show you something, right? So I'm going to show you something. You'll realize that here we got our x as 28.9 sine 60. Let's use this right angle triangle that Lindokuhle is highlighting. So this will be like this, like that, and like that. And this is 30, this is y, this is x, and this is 28.9, right? Then to find x, this is going to be adjacent and hypotenuse, so it's going to be cos. So it will be cos 30 equals to adjacent x over hypotenuse 28.9. So our x is 28.9 cos 30. And Prince, your question, we then put the negative because we are saying we are resolving in the x direction. But if you look, the x direction in this case is in the negative side of the x-axis. The positive side of the x-axis is this side. This is the positive of the y, and this is the negative of the y. So the reason why we are adding a negative sign here is to show that our vector is in the negative direction. That's why we put that. Now, Lindokuhle, if you look at this, we have sine 60 there and we have cos 30 there. And guess what? If you punch in your calculator, sine 60 is equivalent to cos 30. So let's punch sine 60. Sine 60, we get 0.866. Then let's punch cos 30. Cos 30, 0.866. So we get the same answer. So the point is you can form a right angle direction in any way. You can either use this one, or you can use the one that we have put now, this one. Okay, so what you have to be careful with is the angle that you are going to use. when resolving in the x direction. So any angle there, either 60 or the triangle with 30, they'll still give us the same answer. Why? Because we would have resolved looking at which triangle have we formulated. Right, so Prince has confirmed that he has understood. That's good. Thank you for confirming, Prince. Lindobuhle, have you understood what we have just presented there? Make a comment if you are still available. Lindobuhle, make a comment. Did you manage to follow? Yes or no? Do you need me to explain again? Lindobuhle, are you still there? Should we proceed? Did you understand that we can either use the with the 60-degree or the triangle with the 30-degree? I don't see your comment. Maybe we have lost her there. So when she responds, then we will be able to assist her if she needs any further assistance. But in the meanwhile, we are going to proceed. Okay, Lindobuhle says, no, isn't k supposed to be 180 minus 30? No, not that way, Lindobuhle. I think you are missing it somewhere. Can you see the angle K that I'm referring to? The angle K is this angle, right? It's this angle that we are referring to. Is this the same angle that you are referring to? We're not yet looking for the resultant angle. The angle K that I've put there is the angle or if I am to redraw, this is what we have, right? If I am to redraw, this is what we have. If I'm to redraw, this is what we have. And this is 60 degrees, right? And this is the angle K that we're talking about. And this is 90 degrees. So to get angle K, it's 30 degrees. So that if you add 30 and 60, you'll get 90. Okay. So I see you have confirmed that you understand. So even the concept on resolving or choosing which triangle, it's all up to you. Okay, you could have used this one or you can use this one, as long as you use your trigonometric ratios correctly, there is no problem. Okay, so we were here to find and we were using this triangle. So r in the x for vector number 1, it's 50 sine 30, and in this case we don't put the negative prints. Why? Because it's already in the positive x-axis. It's in the positive x-axis, so we don't add that. Then we add, but what we are adding, we found that it's negative. It's in the negative side of the x-axis, so it's negative 28.9 sine 60, right? But if you have used this triangle, then this will be 30, and then your x, you are going to put negative 28.9 cos 30. Okay, that's what you are going to put there, Lindobuhle, if you have used this triangle, this one. Okay, but in this case we didn't use it. But I've already shown you that if you punch this and this, you get the same value, because cos 30 and sine 60 are equivalent. So let's use the triangle that we have highlighted. Okay, so now let's punch. Thank you for your comments and interaction, guys. Glad that you are following. It's good to have people here on the chat who will be commenting, so that I know that we are sailing together. So 50 sine 30 minus 28.9 sine 60. Uh-oh, I was supposed to close the bracket there. Okay, so if I punch, this is what I get, 0.03. Let's go to negative 0.03 newtons. That's for the x. We do for r in the y. Again, we are looking at the triangles that we already formulated. Okay, so on triangle number 1 there, we are now looking for y there. Okay, so I'm going to put the working here. So solving for the missing side, the y component of vector 50. So this is the adjacent. As you can see, it's between the angle and the right angle, so it's adjacent, and this is the hypotenuse. So this is going to be cos 30, and the adjacent is y over the hypotenuse 50. So y is going to be equals to 50 cos 30. All right, so this is going to be equals to 50 cos 30, right, plus we do for this triangle now, and you are looking for this y, right? We're looking for this y. And here it's again an adjacent side. Y is on the adjacent because we've got our angle and we've got our right angle. So we're looking for adjacent and we've got hypotenuse. So it's still going to be cos, and this is 60. Cos 60 equals to adjacent, which is our y, over the hypotenuse, which is 28.9. It's 28.9. So our y is equals to 28.9 cos 60. So it's positive because they are all on the positive side. So that's going to be 28.9 cos 60. So if you had chosen to use this triangle like this, you were going to be looking for that angle, and this being 30, this was going to be opposite and hypotenuse. So this is the same as 28.9 sine 30. Okay, so it will give you the same answer. If you punch cos 60 and sine 30, they give you the same answer. Are you following, guys? Give me feedback if you have understood what we have done, what we are doing. Now let's add for y. That's 50 cos 30 plus 28.9 cos 60. Cos 60. I get 57.8. That's in the y direction. Comments, guys. Are you following? Have you understood what we've done there? I can see Lindovish is confirming that she's following. That's good. I'm happy. So I'm just going to erase this so that we have space. You already know what we were doing here. So to find the direction, now we have to sketch to see which quadrant we are going to be. So our x is negative, so we should be here, and our y is positive, so we should be in that quadrant, the second quadrant. Okay. Now we can use our angle there in the eye to be theta, and if we close there, make this our right angle triangle, our y is 57.8, our x, we got negative 0.03. You see where the negative is coming in again there, Prince? Yeah. So to get this angle, we then use our ratios. Tan theta is equals to y over x. So theta is arctan, our y is 57.8 over 0.03. Then we have to punch that, clear that main function, arctan. .8 over 0.03. We get our theta is 89.97. But is this our answer? Certainly not, right? Remember, we should move from the x-axis up to there, and we'll call our angle alpha, which is equals to 180 degrees minus 89.97 degrees. So we'll get 90.03 is our answer. Right, thank you for following. Thank you for following. So we have the last question that we want to look at. It's also an interesting question. So if you are happy and you are following, let's quickly do the last question that we have here. So again, we need to first find r in the x and r in the y. Okay. So for this vector, it's quite interesting. So what we have there, so this is what we have, and this is what we have there. Just putting the x-axis. So if I am to put the x-axis like that, this is what we have. All right, and we have this vector, which is 10 newtons, and I'm going to put the axis for this vector. Okay, so y, this is x, and this is 10 newtons again, and this is our vector b, this is our vector a. Right, so if we were to extend there, and from there to there, we're told it's 105 degrees, and from here to there it's 30 degrees, and to resolve this, you should recall your z angles, right? Z angle, if you do your z angle, this angle here is 30 degrees. What will be the angle x? What will be the angle x? Because we need the angle x to resolve in the x and to resolve in the y. What is the angle x, guys? Could you please give me the angle x? Someone to type in the chat box. Those on Teams, you can unmute and share with us what is the angle x, because we need that angle x so that we can resolve in the horizontal and resolve in the vertical as well. Okay, Prince says it's 45. Linda says it's 75. So we have two answers that we have, meaning we should add these two answers and divide by 2 and get an average, right? It's that what it means, guys? We should add the two of your responses and get an average. $45, $75. Anyone who wants to explain how they got their answer? Okay, so Prince is saying there's a straight line, and a straight line adds up to what? Angles on a straight line add up to what? Angles on a straight line add up to what? Angles on a straight line add up to how many degrees? So angles on a straight line add up to 180, right? Yes, thank you for confirming that, Prince. Okay. So I don't see Lindogushe's response there yet. Maybe she's still typing. But well, what Prince is saying is correct. How? If you look at this line from there all up to that point, this is a straight line, right? And angles in a straight line add up to 180. So 180 is equals to 105 plus x plus 30. So which means x will be equals to 180 minus 105 minus 35. And this should give us 45 degrees. So angle x is 45. So Prince is correct. If you manage to comprehend this, Lindogushe, how we have arrived and obtained our x to be 45 rather. So we've simply used the principle that angles on a straight line add up to 180 degrees. Now that being said, we can put our angle there, which is 45. We're going to need that angle. And we'll remove this now that we have understood. We are going to close there, right? And for this one, we are going to close there so that we have a right angle there, a right angle there. Okay. Okay, Linda has confirmed that she got it. So now we need to find our components Rx, So I'll call this triangle 1, and I am going to sketch the triangle here. That's 90, that's 45 degrees. And this is our y, this is our x, this is our hypotenuse, which is 10. And we are resolving in the x, right? So x is already on the adjacent, so we're going to use cos. So it will be cos 45 equals to the adjacent x over the hypotenuse, which is 10. So x is equals to 10 cos 45. And because we are on the negative side, if you look at our origin, we are on the negative side. So this becomes negative 10 cos 45. So r and the x is going to be negative 10 cos 45. All right. Then we come on to triangle 2. So this is triangle number 1. We're going to redraw triangle number 1 there. It's 30 degrees, and this is our hypotenuse, and this is our x-axis, the y-axis. This is triangle number 2. And so this is this triangle, right? So we are looking for the adjacent, as you can see. So our x is going to be 10 cos 30. Our x will be 10 cos 30. So we then add, so this one is already in the positive, so this becomes plus 10 cos 30. Okay, 10 cos 30. If we punch that, this is the same as 10 cos 30 minus 10 cos 30 minus 10 cos 45. Cos 45. We get 1.59 rather, 1.59 newtons, right? We move on using our triangles, R in the Y, we work out for the first triangle, which is this one. We're now looking for the opposite, so it's going to be sine, right? So y is going to be equals to 10 sine 45, and here y is going to be equals to 10 sine 30. You can do it the longer way if you like, which is always safe, by the way. So we now add, so they are all positive, right? Because they are above. So that becomes what? 10 sine 45, 10 sine 45 plus 10 sine 30. You add that. Sine 45 plus 10. I get 12.07. So they are all positive, if you notice, right? They are all positive. So I'll just write here. So sketching the quadrant, they are all positive, y is positive, x is positive. So which means we are in this quadrant, right? And what is our y? Our y, we got 12.07, and our x, 1.59. We now know that we use tan theta, right? So theta is equals to arctan y, which is 12.07 over 1.59. clear that second function at 12.7 over 1.59. We get 82.5. We get 82.5. If you are punching me, this is what you are expected to get. Right, this is the end of the questions that we had. So we started by solving questions that were in the PHYV 101 tutorial from question 11 to 15. So I realized you guys joined quite late, but thank you for still making an effort to join. Were you having a lecture earlier on at 12? Were you occupied? Were you having a lecture? Were you having a lab session? What were you up to from 12 to 2? Between 12 and 2? Oh, I see. Transport. All right, that's fine, guys. Thank you for joining in. From the bit that you had a chance to see on what we're doing, would you have any questions? So for the questions that you probably have missed, you'll find these questions on the recording on YouTube. You can go over them again. If you missed the earlier touch sessions, whether for the FVV or for the PHYV 101, you'll find the recordings on YouTube. Okay. So any questions that you might be having? Otherwise, we end our touch session here. So if you joined late, you realize that we have been streaming for the past 2 hours. So go through the recording and follow through, and perhaps you may have questions. Be sure to ask in the next session. Oh, that's a comment from Prince. He said the last question needed some serious thinking, how to solve high orders. Yeah, perhaps we can say so. So I remember I've been taught about safe physics. You've been taught about safe physics. Do you remember that? That first and foremost you have to sketch, alright? Then you have to put your forces on an axis, then you have to sum the forces, right? So this is what we started with. We started by putting our sketch. We put our 10 Newton force, then we put the axis. And for this one again, we come to its tail, we put the axis. Once you have done this, your problem is already half solved. You realize it's already half solved. Then what you have to do is now to find this angle, right? Using your knowledge on angles. Okay. Once you've done that, it's now a normal problem that you are used to. So you should have just used your concept on safe physics, step by sketching. Put your forces, you put your axis, then you can now sum the forces which are in the same direction. Alright, it's good that you managed to realize that. How about Lindobuhle? Did you manage to grasp the last question? All right, I see Nobody has responded. He has managed to follow. So like I said, in case you missed any recording, you'll find it on the YouTube channel. Be sure to subscribe to the channel so that when we start streaming, you are able to get a notification. Alright guys, thumbs up to you for your contributions, for your questions, for the interaction that we had. It was a pleasure to be having you here this afternoon. So in case you want to go and over again on the questions, please do take time to go over the questions again and again. Practice resolving, practice finding the magnitudes and the angles of a vector, and practice safe physics. So from me and everyone in the studio, it's a goodbye. See you again in the next tutorial session. Bye.